In this video, we're going to be discussing Module 4, Exponents and Polynomials. We're going to start out with the exponent rules. It's very, very important that you spend some time and get comfortable with these rules, understand these rules, and know them, okay? So a to the 0, that means really anything. They use a as the base, but we could use any number. If I said 8 to the 0, this would also equal 1. Any number raised to the 0 power equals 1. Any number raised to the first power equals that number, right? 16 to the first power just equals 16. Next is when we're multiplying. So when we multiply two numbers with the same base, so a to some exponent times a to some other exponent, we're going to add the exponents. And I'm going to go ahead and show you this using numbers. So if we had 3 squared times 3 cubed, this rule says we'd have 3 to the 2 plus 3, which equals 3 to the 5th power. And if this were a problem on the test or on a quiz, you would want to go ahead and evaluate. Hopefully we all remember what exponent means. 3 to the 5th would be 3 times itself 5 times. 3 times 3 times 3 times 3 times 3. What we can also do is go ahead and show it. So 3 squared equals to 3 times 3. Times 3 cubed equals to 3 times 3 times 3. Then I can add up how many 3's do I have? 1, 2, 3, 4, 5. And I still get 3 to the 5th. The rules will make it go a lot quicker, but you can use the definition of what an exponent means to actually figure out what it should be. Division, similar thing. We're going to have a to the m, so some base to an exponent, over the same base to another exponent, then we're going to subtract. So if we use the same numbers, 3 cubed over 3 squared. If I go ahead and write this out as 3 times 3 times 3 over 3 times 3, right? That's what the definition means. Anything over itself is going to equal to 1. So these are going to cancel out, which means I'm going to be left with 3 to the first power, or just 3, right? We wouldn't write 3 to the first power, we would just write 3. If we subtract here, we get 3 to the 3 minus 2, which gives us the same answer, 3 to the first power. So you can see that either method will work. Negative exponents, anytime that you have a negative exponent, you're just going to move it across the division bar. So right now this a to the negative n is kind of like it's over 1. I'm going to move it to the bottom and move the 1 up. When it's on the bottom, I'm just going to move it up. Now this only works for negative exponents, not negative numbers, and we only want to move negative exponents. We do not want to move positive exponents. That would be incorrect. A to the m raised to the n, so this is a power to a power, so this looks more like 3 squared cubed. We are now going to multiply those exponents. So 2 times 3 would give me 3 to the 6th power. Again, can still use the definition. 3 squared is 3 times 3, and we want that cubed, so we want that to happen 3 times. So 3 times 3 times 3 times 3 times 3 times 3. How many 3's do I have? 1, 2, 3, 4, 5, 6. 3 to the 6th power. Okay. When you have in parentheses AB to the same exponent here, you're just going to distribute that to each A and B. Same with division. A over B raised to the n will give you A to the n over B to the n. And to the negative n, you're going to distribute first A to the negative n, B to the negative n, and then we will move it each one across the division bar to give you a positive exponent. In general, my math lab is going to want a positive exponent. It's not going to want you to answer in negative exponents. So you can see on the problems, write the result using positive exponents only. So negative 2 to the 4th power, I want you to think of this as the opposite of 2 to the 4th power because there is not parentheses. So this is equivalent to negative 2 to the 4th power, or the opposite of 2 to the 4th power. So we have the opposite of 2 times 2 times 2 times 2. 2 times 2 will give me 4 times 2 times 2 gives me 4. Still have my negative out front, so my answer would be negative 16. 7 to the negative 2. Again, we don't want to answer with a negative exponent, so we're going to go ahead and just move this to the bottom of a fraction, 7 squared, and we put a 1 on top. Okay? 16x to the 0. This is a common one that gets missed. What this says is 16 times x to the 0. Now, x to the 0, anything to the 0 power is equal to 1 times the 16 I already have. This 0 power is not a part of the 16. These are two separate pieces. 16 times 1 would give me just 16. Versus if they gave us 16x to the 0 power. Now the 0 power is being distributed to both the 16 and the x, and this would be equal to 1. So moving into a little bit more challenging, we have 9x cubed, y to the 4th, negative 2x to the 7th, y to the 5th. So when we multiply, we're just going to match up the same thing. So the bases. With numbers, we're going to multiply the numbers times the numbers. So I'm going to have 9 times a negative 2, and I'm going to write these in there, each one in their own little set of parentheses. X cubed times x to the 7th, and then y to the 4th times y to the 5th. Now we can apply our exponent rules. So a 9 times a negative 2 is just negative 18. And then x cubed times x to the 7th, if you remember, when you're multiplying the same base, we add exponents, so it becomes x to the 10th. Same thing for the y's. We get y to the 9th. Add the exponents there. And this would be your final answer. Division, again, now we have subtraction, right? We have p squared over p, so we have p to the 2 minus 1. When there's nothing written, we write as a 1. Times q to the 5th minus 3. So 2 minus 1 would give me just p, and q with 5 minus 3 would be q squared. And you can use the definition to write this out if that helps you, especially in the beginning when you're first getting comfortable with the rules. It's a very good technique and tool to have. Now we have negative 7r to the 4th, s to the 5th, raised to the 3rd power. So we said that when it's in parentheses like that, we're going to distribute this to each part that's inside. So we get negative 7 cubed times r to the 4th cubed times s to the 5th cubed. And now we have a power raised to a power. Negative 7 cubed is just negative 7 times negative 7 times negative 7. And you notice that this one was in parentheses, so this is a negative 7 being multiplied by a negative 7. R to the 4th raised to the 3rd power, I'm going to multiply those exponents, so I'm going to get r to the 12th. S to the 5th raised to the 3rd power is going to be s to the 15. So -7 times -7 times -7 will give me a -343, r to the 12th, s to the 15th. Now everything has a different base, so we cannot combine any further, and that would be our final answer. Okay, so now we have -3x to the 4th over 4y cubed, all raised to the 2nd power. Again, we're going to distribute the square in to all of the pieces. So -3 squared, again, it's in the parentheses, x to the 4th squared over 4 squared y cubed squared. And then just take it in little pieces, do it one by one. -3 squared would be -3 times -3, which is a +9. X to the 4th squared, I'm going to multiply those exponents, so I'm going to get x to the 8th. I'm not going to square 4, so please be careful of that. 4 squared would be 16, 4 times 4. And then y cubed squared would be y to the 6th. Again, we're going to multiply those exponents. And this would be your final answer. Nothing can simplify, nothing can come out. If 9 over 16 could be simplified, then you should do that. X squared over x to the -3. First thing you want to do is get positive exponents. So hopefully you remember that if I have an x to the -3, I need to move it across the division bar to make it positive. So I have an x squared on top times x cubed. And now when I multiply with the same base, I add my exponents. So I get x2 plus 3, which equals to x to the 5th. For x to the -7 over x to the -4, I'm going to move x to the -7 down and x to the -4 up. So my new fraction will be x to the 4th over x to the 7th. Now I need to remember that I need to subtract. So I get x to the 4 minus 7, which equals x to the -3. 4 minus 7 equals -3, which means I cannot answer a negative exponent in my math lab. It will mark you wrong. So I need to now move this to the bottom of the fraction and put it at 1 on top. This would be the answer that my math lab is looking for. And if you think about this, if we go back to x to the 4th means x times x times x times x over x to the 7th is 7. And then we cancel out what's the same. X over x would cancel out. Again, x over x would cancel out. X over x would cancel out. And x over x would cancel out. I'm left with 3 x's in the bottom. So I need to reflect that in my final answer by writing 1 over x cubed, because this is times 1 up here. Remember that wherever my larger exponent is in the beginning, that is where my answer should end up. 7 is larger, it's on the bottom, my answer should end up on the bottom. Five, x to the 4th, y to the -5, all raised to the 4th power. So we're going to distribute this 4 to each part in here. And I'm going to go ahead and write it out. So 5 to the 4th power times x to the 4th power times y to the -5th to the 4th power. Okay? 5 to the 4th power is just 5 times 5 times 5 times 5 in your calculator, right? That's what you should put in your calculator. X to the 4th raised to the 4th power means I do 4 times 4, which gives me x to the 16th. And y to the -5 raised to the +4 would give me a -5 times 4, which gives me y to the -20. So 5 to the 4th gives me 625. X to the 16th should stay where it is. It's positive. But y to the -20 needs to be moved to the bottom of the fraction to make it a positive. It becomes positive when you move it down, and we want to make sure that we don't move anything that's got a positive exponent already. And then this would be the final answer. Number 11, m to the third power over 8n raised to the negative 2. Again, we're going to distribute the negative 2 into each one. So I'm going to have m to the third power raised to the negative 2 over 8 to the negative 2 times n to the negative 2. Please, please, please don't ever evaluate a negative exponent, okay? If you evaluate this, you will most likely forget to move it. So we want to move it first. We want to move it to the top of the fraction to make my negative 2 into a positive 2, which will give me 8 squared. And then I can evaluate it once I've moved it. If I do m cubed, I would get m to the negative 2. I would get m to the negative 6, 3 times the negative 2 over n to the negative 2. And now both of these have a negative exponent, which means the m needs to go down and the n needs to come up. So my final answer would be 64, 8 times 8, n squared over m to the 6th.